The problem that we'll be solving is maximal sum path. Here we are given a binary tree, which is just a structure where each node can have up to 2 child nodes. The tree starts from the root node at the top. So we can see here the root is 3. This tree information can be stored in a list from left to right, level by level. And here we can see there are some none values, which means there are no node at that position. So what is expected here? We have to find the maximal sum path. It is the path whose sum is the greatest. So we can see from the root there are some paths that have been found. From 3, minus 2, 9. From 3, 5, 2, 1. Then 3, 5, 2, 3 and 3, 5, 2, negative 3. Here our task is to find the path that has the highest sum of the elements here. The tree is represented using a list, and the output is the path along with the sum of the elements of this path. Now we will discuss how to solve it, and in manual way then we'll try to solve it using Python. So let's understand the relationship of the list expression of the tree and the actual tree. So this is the tree and these are the levels. Now let's see what the list expression of the tree is. Now this is the list expression. So what it does, the elements are put level by level. So let's check how it works. So this tree is the root. Then we have minus 2 here. We have 5 here for level 2. Then the next level we have 9. Then we have a none. By the way, here just to understand it easily, I have put n instead of none. So understand, whenever you see n here, it would be none. So this none was supposed to be a child of minus 2, would be the right child minus 2. Then we have 2 here, 2 here. Then we have none. This none is the empty child or non-existent child of 9. Then we have another non-existent child of 9, the right child. Then we have these 2 other nuns as well. Those would be other 2 non-existent children of this none. Then we have 1 which is here. Then we have none which is the empty place for the right child of 2. Then we have 3 and minus 3. These are here. So that is how it is expressed, and we should know another thing. And that is, for any node n, the left child index would be 2 into index plus 1, and the right child would be 2 into index plus 2. So for example, here the root in the list, the index is 0. So its left child would be using this formula 2 into 0 plus 1, which would be 1. And the right child would be 2 into 0 plus 2 would be 2. And we can actually see that yes, the root, its right and left child are 5 and minus 2, which has the index correspondingly 2 and 1. And we can check for any other elements as well. For example, let's say we can check for this 2. So what's the index for this element? It's 0, 1, 2, 3, 4, 5, 6. So based on the calculation, the left child is supposed to be at the index in this list would be, so 2 into 6 would be 12 plus 1, 13 would be left child, and 14 would be right child. For which element? For this 2. So where is this 2? Okay, so let's see 13. So 6, 7, 8, 9, 10, 11, 12, 13 and 14. So this is 13 and this is 14. So now if we look at the tree, we can see, yes, this is the parent and this is the left child, this is the right child, which actually matches the formula. So that is how we can make the structure of a tree using list expression. Now we'll jump in the code and solve it. For this problem, let's take the input first. And the input is already shown that a list will be given and we'll have to put all the elements level by level. It is the input and we are going to split. Then what we will say that we will convert each of the elements into corresponding values. So currently we have a list of strings here. So now if the element of this list is none, as string we'll convert it into none value, otherwise we'll convert it into integer, and that is how we do it. Next, we'll create another function which is Maxiamal Sum Path, which will take the nodes. Now we will call this function in the main function and then get the result. So this is how I'm going to call. So this function will return the maximum path result and the result maximum sum. And I will print both of them, the maximum path. So the maximal path is supposed to be printed first. Now we'll work in this function and try to solve it. As we have previously studied, we're supposed to apply DFS with recursion for tree here. So the inside function DFS, it will take index and this will be the recursive function. So the initial condition will check for the index. If it's greater than the length, that means it's out of the boundary, then we'll just simply return empty, because it's not supposed to be less than 0 or more equal to or more than the length, which is out of the boundary. Now what we will do? We will define the left and the right child. So this is the left child as we previously discussed, and this is the right child and their index. Now we will check sum from the left child and sum from the right child, and then we will compare them, and whichever is higher, we'll put that as the result for the next level. So here we will call the recursive function. So here this DFS is called, and it's recursively called with first index of the left child and secondly the index with the right child. And now we will compare these two sums. Now if left sum is greater than right sum, then left path will be included and this will be returned. Otherwise we'll return the path for the right child. Finally, the maximum path and the maximum sum will be returned in this function, and that will be returned to the main function. So how is it supposed to be done? So we are calling the DFS function here with the index for the root, which is 0, and then we are getting the result here, and then we are returning the result to the main function. Now we are calling the function here with the index of the root node, which is 0, and then taking the result max path and result max sum here and returning to the main function. So now we will write this. Now we will run this function and see whether it works for our test case. So I have made some changes here. The first change was here initially it was nodes, but it's supposed to be tree input. That's the first one. And the next edit was here, it was nodes, but it's supposed to be node. So I have fixed those and I'm running this and I'm inserting the test case, and it gives me the correct answer because it matches the expected output of the example. Now I'll submit this code in the website and see whether it works for all the test cases. Submitting this code and I'm waiting for the result. Yes, so the solution works for all the test cases and we have successfully solved this problem. And thank you so much for staying with me for the whole class, and I hope you best of luck and try to solve as many problems as you can. Thank you so much.